friends, my name is Nitesh. Shet. I am from Manara. So this is the right time to start the part of physics in 9th standard. So firstly I will take the first chapter of physics in science, that is describing motion. So dear students, in this class we have to discuss about describing motion. Okay, just I will explain about the title. It is so describing means it's an explanation. So explain about motion. So motion in term derived from the moving. So the moving of an object is very essential with the motion. So this is the very similar words, moving and motion. The objects are moving, the persons are moving, the friends are moving. So like that, the earth is moving, the planets are moving. So likewise we are taking it as a motion. So in 8th standard we already discussed about some of the state of motion. When the force is experienced on a body, so the particle moves or the object moves here. So in that case we are taken it as a motion or moving of an object. So any case of a motion of an object, so consider all the cases, so there is some changes is there. So when the force acts on the body, so when the force, so our this is a box here, so I will apply one force here, so my hand is moving here, hand is moving. After application of force, another body, so another body, so when I am applying force, so that body in motion. So that means the motion is because of the cause of force is also a motion, and also after the application of force is also a motion. It results also motion. So that is nothing but motion. The motion is very essential in our day-to-day life. That is, in everyday life we are moving. So when we have to decide to go another places or like that another villages like that. So when we are having to move or when we have to change one place to another place, so there is required this motion of an object. Yes, this is about motion. So just I mentioned about change in place. Yes, so that's a very essential part in our motion, describing motion. That is, it's a change in place with respect to time or with respect to reference point. So here there are two terms appears. So when we are considering the time, time is one of the quantity. So we already learned that one of the physical fundamental quantity is time. So we are measured in seconds. So we have to measure the motion in case of time. That means, so how fast he moves. Yes, when fast comes. So there we are taken it as a with reference to time. Or so how much fast he passed from me. Yes, then I is the reference point here. Here me is the reference point. I am describing that motion, how fast he is, then how speed he is. Yes, so that means, so here we require one reference point or with respect to time when we are describing motion. This is about describing motion. When we have to describe the motion means, so we have to take one of the reference point or reference time, or with respect to time we have to take here. So let us describe motion. So already we learnt that when we are defining any physical phenomenon, we have to take some of the basic quantities, that is what, why and how. So what is motion? So here that term is meaningless here, because so when we are taking the phenomenon of physics, so we have to take that one. But when we have to take the phenomenon of physics, so this comes the action of muscles here. So likewise we can take that one. So we have to apply some of the forces. So like that. So here motion is nothing but it's a phenomenon of physics. So only we can neglect that part. Okay. So after that we have to describe that motion. Motion is a change in position of a body or change in position of an object with respect to time or with reference to a point here. So that is, so motion is nothing but, motion is nothing but a change in position of an object, position of an object, position of an object with respect to to time, with respect to time, or with respect to reference point, with respect to reference point here. Yes. So consider you are the reference point here. Just observe this motion. Yes. Here the change in position of an object. Here from here to here. So when I am the reference point. So here to here. So it comes from this place to this place. Yes. So here when we are describe motion means, so when the body changes its position from one place to another place, we are consider it as the object is moving or the object is in motion. So that's why. So this is about the describing motion. That is our explanation about motion. So let us go with some of the examples. You can give many examples are there in our surrounding. So that means the vehicle is moving. The motion of a vehicle. Motion of vehicle. Then flying birds. As flying birds also example for the motion. Then this is not restricted to our earth. This is beyond earth also there is a motion. So that means the motion of a planet. Motion of planets. Then revolution of planets also, revolution of earth. Revolution of earth. Yes. So revolution of earth. How can we describe that motion? So we are experiencing some of the time. That is one time summer and rainy season. So also some of the seasons are there. We are experiencing that one. So from the revolution of earth, so we can describe it as a motion of an earth, or we can take it as a revolution of earth here. So this is about motion. So when the object is changing the position, so their position, so we can say it as the object is moving, the object is in motion here. So let us move on to the next topic. Yes. So motion along a straight line. The next topic is the motion along a straight line. So just observe this sentence, that is motion along a straight line. Straight line we already know that. So in the same direction. When we have to describe that one is in same direction, the motion of an object. The motion of an object in the same direction or straight line. That means when the object allows or when the object takes the straight line path or in the same direction, we are call it as a motion along a straight line. It is when an object takes a straight line path, or when the object moving in a same direction, moving in one direction. Yes, in this case we call it as the motion along a straight line. That means the object is moving in a straight line. The object is moving in a same direction, in a unique direction it is traveling. So that part we are call it as a motion along a straight line here. In light, when we are taking the light as it's a rectilinear motion. So we are taking it as a rectilinear path, like that we have to take that one. So here motion along a straight line or rectilinear motion we can take it as. So when an object takes a straight line path or when an object moving in a one direction, in the same direction, means the object is in motion along a straight line here. So here we can call it as a motion along a straight line. So here I just wrote on straight line here. That means it's a line, the straight line we are represented here. when the object, then it's an initial point, it's a O, I will call it as O, it's an initial point. So after some time, so he travels to 90 centimeter or 90 kilometer, 90 meter, whatever it may be, we can assume all the things here. Okay, so here up to A, so he traveled up to A, after that he comes back to 50, then he comes back to 20, and finally he comes to the initial position here. So this is the straight line path when the body moves from 0 to A, so O to A, so then O to A, then we can say it as it's also straight line path. That means the object is in motion along a straight line. When the object comes to the point B, that means here also the body is in straight line. That means from A to B, it's a straight line path. So the body is in, the object is in motion along a straight line. Also B to C, also C to A. That means here the body is moving. The motion of an object is in a unique direction, in the same direction here. Yes. So this is about the motion along a straight line. Based on that, there are some of the parameters are there we are expressing in these classes. So that is, so here also it is describing motion. That means here we are describing how much quantity or how much quantity the object moves here. So in physics we are explaining all the things in the case of some of the parameters, length and time. So here also we are expressing in the case of length and time. So when we are taking the length, so it's only the scalar quantity. We already learned that. That is, so when the body, so when any physical quantity having only magnitude but not direction, we are call it as a scalar quantity. When the quantities are having both the magnitude and direction, we are call it as a vector quantity. So here we are taken, so here there is no any time reference here. So motion along a straight line, here we can't take any time reference, how much in some time he travels here. So there is no any case, but he travels along a straight line, he covers some of the distances here. So yes, so that means here there is a one word comes here, that is distance travel. So that means here we are discussing about motion, here we are describing the motion. So for that we have some of the parameters of motion, that is the two parameters are there, that is one is the distance traveled, another one is the displacement. Distance traveled and the displacement we are discussing in this class here. Okay, so let us take distance traveled. Distance traveled. Distance traveled. Yes. So here distance traveled, or we can say take it as it's a path length. Path length. So we can call it as a path length also. Yes. So distance traveled means during the whole journey. So that means here the whole journey starts from O and come then A, then B, and then C, then O. So that means the whole journey starts from O and ends to O also. So that means, so here the object starts its journey from the initial position and finally after comes to the initial point. So this is about the motion along a straight. Here the motion along a straight line we are discussing about. Also in case of here describing motion, that is we are discussing about some of the parameter. One of the parameter is distance traveled and the path length. So that means here the total journey, we are calculating the total journey of an object. That means total change in position of a time or total path length covered by an object is known as distance traveled or path length. That is total path length covered by an object. Total path length covered by an object is known as distance traveled. Distance traveled. Yes. So look at here. So here the object starts from O. So here object starts from the point O, then comes to the point A, then comes to the point B, then comes to the point C. So whatever be the journey. So this is not restricted to motion along a straight line. So whatever the case, we have to take the total journey here, the total distance traveled during this journey here. So that means here we have taken it as a total distance traveled is equal to distance traveled is equal to. So how can we take that one? Firstly, it starts journey from O, then comes to A. That means so we can include OA, then A to B. That means we can take AB, then B to C. We also taken it is BC plus then CA. Finally CA. Here, how much here OA is equal to 90. Then just AB. AB means here 50 to 90. That means here only 1, 2, 3, 4. That means 40 meter only. So it is 40. Then here 1, 2, 3. That means 30 meter. Then CA means only 20 meter or 20 kilometer. Yes. What is the total distance traveled here? So here 30 plus 20, 50, 50 plus 40, 90, 90 plus 90, 180 meter we traveled. That means, so here the total distance traveled by an object is 9 to 180 meter he traveled. Yes, this means, so it is a total distance traveled. So just observe here, there is only a magnitude. We can't take any direction here. So we calculated the whole journey here. So that means there is no any direction. So only magnitude is there. So that's why the distance traveled is a scalar quantity. That is distance traveled is a scalar quantity. Then, so all the physical quantity has their SI unit. That means here we are expressing this distance traveled in the case of meter. That is SI unit of distance. Distance is meter. We are taking it as a small. So this is one point. This is the second point. So this is about the definition. That is the total path covered by an object is known as distance traveled, and distance traveled is a scalar quantity, and SI unit of distance is meter. So we are expressing that distance or the total journey in case of meters. So let us move on to the next parameter, that is displacement. Yes, so displacement, just observe the word, that is displacement. Placement means, so we have to shift a body from one place to another place. That means we are taking it as a placement of an object. So place that object here. So likewise we are taking, that is, so from the word we can express it as a displacement. That is, it's the shortest distance between initial point and the final point. That is, when we are shifting, so here one object is there, I will shift this object from here, from this position to this position. That means it's the shortest distance. So here we have to take the direction here. So shift this body in this direction. So shift this body from this position to this position. So that means here there is no any case of total distance traveled here. So that means from which to which the body displaced here. Yes, so from which position to which position the body is displaced here. So that's why we are taking it as a displacement. That means here there is no any case of total distance traveled here. So we have to calculate the distance, how much quantity the body displaced here, which direction the body displaced here. So that's why we have to take here only. So that is, displacement is nothing but it's the shortest distance between initial and final position. That is the shortest distance between initial and final position. Yes. Also, we can express in the case of motion also. It's a changing position of an object. The change in position of an object in particular direction. That is, we can say it as, or we can say it as a change in position of an object. Change in position of an object in particular direction. In particular direction. So that means here the change in position of an object occurs in particular direction. So when the quantities are having both the magnitude and direction, means that quantity is nothing but the displacement. That is, here it is a vector quantity. It is a vector quantity. It is a vector quantity. Also, this quantity we are expressing in terms of SI unit meter. That is the SI unit of displacement is meter. So meter we can take it as an M. So here, so this is about displacement. So it's a vector quantity. The SI unit of displacement is meter. So let us come to this case. Here the body, the object travels its journey, or covers its journey from 0 to O to A. After that it comes to B, and after that it comes to C, and after that comes to O. That means here the initial position and final position are same here. Here initial position and final position are one and the same. That means, so the displacement is 0. So that means here the change in position in particular direction. Here the total change in position is O to O only. So that's why there is no any change in position. So in particular direction. Here some of the cases arises. What happens when object covers a distance of OA? What happens? So we have to discuss by some of the cases here. In case of displacement only, so here we have to describe it. Yes. So I will taken some of the cases here. Case 1, that is when an object covers a distance OA. When the object covers a distance OA. Yes. So here, firstly I will consider the point O and A. Here, initially the object is in the point O, and after that it comes to the point A. So that means here the total distance traveled is, what is the total distance traveled here? So 90 meter is the total distance traveled. That means here what is the distance traveled here? Distance traveled is equal to 90 meter. Then what about displacement? So here just take the displacement, that is, see here the total path length or changing position of an object in particular direction. So here it's in the straight line. That means, so when it's in the straight line here, so then the distance traveled and the displacement is one and the same, because so here distance traveled means it's a total journey taken by an object. Also, when we are taking the displacement, it's the shortest distance between initial and final position. So it's a initial position and it's a final position. That's why. So displacement also 90 meters. Displacement is equal to 90 meter only. So here, when the object moves in a straight line, moves along a straight line, then the distance traveled by an object and the displacement of an object are the one and the same. That means here distance is equal to displacement. Yes. So this is the case of when an object covers a distance of OA. So let us consider the object covers a distance of OB. That is, I will consider here case 2. It is when an object covers a distance OB. Yes. So we have to take water concept. So what is the distance traveled here? Let us calculate what is the distance traveled. Distance traveled is equal to OA plus AB. So that means OA is 90 and AB is 40. So 90 plus 40 is equal to 90. So plus here 40. 1, 2, 3, 4. That means it's a 40. So is equal to 130 meters is the distance traveled. Then what about displacement? When we are taking the displacement, we can take the shortest distance between initial and final position. Here, initial position is this and final 50 meters. 50 meters. Here, when the object changes its direction here, that means then we have to take the shortest distance between initial and final position. Here, the distance traveled is not equal to displacement. That is, distance traveled is not equal to displacement. Distance traveled is not equal to displacement here. Yes. Then consider the next case when the object covers a distance from O to C. So that means the O to first O to A, then A to B, then B to C. Yes. When yes, here case 3, when the object covers a distance that is O, A, B, C. We can take like that. So here, so O, A, B, C. So here I will take O, A, B, O to A and A to B. Here O, A, B, C here. So here the object covers a distance O, A, B, C. First he took the journey from the O and first after that he reaches the point A. Then he covers up to B. Then he travels up to C. That means here total distance traveled is distance traveled is equal to so just observe, so O to A means 90, then O to B means 40, so A to B means it's 40 plus B to C means it's 30. So the total distance is equal to 90 plus 40, 130, 130 plus 30 is equal to 160. 160 meter is the total distance traveled in case of OABC. Then, so we have to discuss about displacement. Then what is the displacement here? Displacement is equal to, just observe, it's the shortest distance between initial and final position. Here 0 to 20, that means it's only 20 meter. Here distance traveled is not equal to displacement. Distance traveled is not equal to displacement. Then let us discuss about the last case. That is case 4. It is when the object covers a distance O, A, B, C, O. That means here the initial position and final position of an object is same here. That means here what is the distance traveled? Distance traveled is equal to. So first we take O to A, it is 90, plus A to B, it is 40, plus B to C, it is 30, plus C to O, it is 20. It is 30, it is 20, is equal to totally 180 meters. Then what about displacement? It's the shortest distance between initial and final position. So here the object initial position and final position are one and the same. That's why here the displacement is 0. That is displacement is equal to 0. Here distance traveled is not equal to displacement. Distance traveled is not equal to displacement. Yes. So this is about some of the description of motion here. That is, so here we discussed about what is meant by motion and what is meant by motion along a straight line. We described that motion along a straight line. Also, from that motion along a straight line, we express some of the parameters, that is distance traveled and displacement traveled. Here I will take some of the cases of displacement and comparison between distance traveled and displacement traveled. It's a describing of motion. That is, so when we are describing motion, when we are taking the explanation of motion, we have to take the two parameters, that is, one is the distance traveled and another is the displacement traveled. So distance traveled is a total journey or total change in position of a time, and here when we are taking the displacement means here it's the shortest distance between initial and final position. So I will conclude this part here. So those who are watching this video for the first time, please subscribe our channel and don't forget to press the bell icon. So thank you one and all. Be safe and stay home.